So let's take our data set for these buildings and try to actually do the correlation coefficient ourselves. And then I'd also like to end up plotting the data and looking at the estimated linear regression equation, which I have displayed there, as well as the r squared value. And so let's see if we can actually make that work. So to do that, I have the data out on Blackboard. It's called buildings.xls. So I'm going to download that. Open it up. And let's make it bigger. So again, we have year, what year the building was built or finished in perhaps, the number of stories, and the height in feet. So we'd like to create a scatter plot. So we said stories is going to be our x variable, height is going to be our y variable. So I'm going to select both of those columns and go to Insert, Scatterplot, and I just want the dots. And it looks like when I do that, it does it correctly. It puts the x variable on the left-hand side, and the height, the y variable, needs to be on the right-hand side. So I'll do that. And then I'm going to come over here and just move it a little bit. Maybe zoom out a little bit now too. There we go. And then I don't like this title, so let's, what do we have it before? Number of stories affect building height. All right. And I would like to add a chart element, axis titles. Let's do horizontal down here. This is stories. And we'll get rid of that. Add a chart element, axis title, vertical. And this is building height. Did I spell that right? Building height in feet. And then I'm not a big fan of grid lines, so I'll get rid of that. And then notice that it starts at 0, 0. Let's adjust that a bit. Looks like the smallest one we have is 28, so let's go to 25 maybe. Let's do 25 and see what that looks like. And then it's also the smallest is 428, so let's do 400 for that one. Forget what I did on the slide. Oh, nope. Format. It doesn't like me today, huh? For whatever reason, alright, so I'm going to format the y-axis. I said let's go down to 400 and see what that looks like. Alright, so that doesn't look too bad. Alright, so after we do this, so I zoomed in on both axes. After I did this, I say, is there a relationship between the number of stories and the building height in feet? And it does look like there is some kind of relationship here. It looks like it's going up like we thought, and it looks like a relatively straight line. We could fit a straight line. Those three look like they hit pretty good. All right. So to fit a straight line, there's lots of different ways to do it. Let's do the simplest one for right now just to see what happens. If I click on one of these data points and right click and do add trend line, we want a linear. And I'm going to display the equation and the r squared value on the chart, and then close this, and then move it over. And we see that we have an r squared value of 0.8809. Recall that that is telling me how much of the variation in the y variable, building height, can be explained by the x variable, the number of stories. So 88% of the variation in the building height can be explained by the story. So pretty good. And then we see that we have the estimated regression equation, which we'll get talk more about in a later video. 176.07 plus 9.4492 times x, where x is the number of stories. So that's the simple way to do that. So now in the following videos we'll talk about what this equation is doing and what we're actually trying to do and how we come up with getting that line. Why is that considered the best fit line?